Today we're going to be working on just some miscellaneous types of conversions. My goal here is to make sure you're comfortable with converting from whatever you're given to whatever you're trying to find. So I want to work through some different examples just to reinforce the thought process, and then I'm going to have you guys start working on a worksheet that's in Google Classroom. So whenever you're doing it, no matter what kind of problem you're doing in stoichiometry, the first thing you want to do is make sure you have a balanced equation. So we actually did this reaction the other day. So I have it up here, and I've already balanced it since we worked through that the other day. And now we're going to look at what the problem is giving us. So it's giving us 115 grams of titanium 4 oxide. It's asking how many molecules of titanium 4 chloride. So just to organize yourself, each time I want you to write down what the problem is giving you and what you're asked to find. So it's telling us we have 115 grams of this. So this is our A. This is our known. It's asking us for the molecules of titanium 4 chloride. So I'm going to put molecules, and actually that should be formula units. So let's actually change that to formula units. And this will be our B. Okay, so we're starting with grams. So if we visualize our island, we're going from mass of A. We always have to go to moles of A if we're not given that. And then we have moles of B. And then this time we're finding molecules. Formula units. So remember, we're going towards the mole, we're dividing. We then use our mole ratio. And we're going away from the mole, we'll be multiplying. Okay, so let's start with the 115 grams of titanium 4 oxide. And like I said before, always make sure your unit has now the compound next to it. So we have grams here. That means grams will be on the denominator, and the compound, the denominator, needs to match up. And since we have grams, it's the other side's going to be moles. And remember, with molar mass, it's always 1 mole of our compound or element. Okay, so let's look at our periodic table once again. Find the molar mass of titanium 4 oxide. So that'll be 47.88 plus 2 times 16, which gives us 79.88 grams. So we notice here grams cancel out, titanium 4 oxide cancels out, and now we're at moles of A, so we're going to use our mole ratio. So again, we have moles of titanium 4 oxide in the bottom, and since we're looking for titanium 4 chloride, we're going to have moles of titanium 4 chloride in the numerator. Okay, so now we're going to look at our balanced equation, look for the coefficients of each of these. And we see up here we have 2 next to each. Now you could simplify that, make them both 1 if you wanted to. But you notice now moles cancel out, titanium 4 oxide cancels out, and now we're left with moles of titanium 4 chloride. So our numerator here has to be moles of titanium 4 chloride. Now, this is going to be Avogadro's number to go from moles to formula units. So remember, with Avogadro's number, this should always also be 1 mole. Only time you see a number other than 1 with your moles is with your mole ratio. Okay, so now we're going to put Avogadro's number in the numerator. And this is going to be formula units of titanium 4 chloride. Okay, so now we notice moles cancel out, titanium 4 chloride cancels out, And then we're going to multiply whatever's in the top, divide by what's in the bottom. So we have 115 times 2 times 6.02 times 10 to the 23rd divided by 2 times 79.88. And that gives us, for our molecules, our final answer is 8 point, and we're going to do it 3 significant figures, 67 times 10 to the 23rd, and this will be formula units of titanium 4 chloride. Okay, so that's a problem from grams to formula units. So let's do another miscellaneous type of conversion. So here we have grams to volume or grams to liters. So first, let's write out our equation. So we have zinc. I think we did this reaction last class. We have zinc reacting with HCl. Remember, this is single replacement where hydrogen gas is released. And then we have ZnCl2. So remember, to balance it, we just needed 2 here. So we have 50 grams of zinc. So that is our known. And then it's saying what volume of hydrogen gas. Okay, and this wording here with excess hydrochloric acid just means there's enough of this that we won't run out before we form our hydrogen gas. So you can kind of ignore that information. So we're asked to find the volume of hydrogen gas. So we're asked to find liters. Okay, so here we have mass of our A going to moles of our A going to moles of our B going to, and I'm going to put here, liters of our B, our volume of our B. Okay, so remember, we're going towards the mole, we're dividing. Going across here, we're using our mole ratio. And then going from moles to liters, we're multiplying. So we have 50 grams of zinc. And then we're going to use our molar mass. So you notice here grams of zinc, grams have to go on the bottom, 1 mole on the top. Look at our periodic table, that's 65.39 grams. And you notice here grams cancel out, zinc cancels out, we're left with moles of zinc. So now we're going to do our mole ratio. So we're at moles of A, now we're going to go to moles of B. So we have moles of zinc on the numerator here, so moles of zinc have to go in the denominator. And then we're looking for hydrogen, so hydrogen is going to have to go in the numerator. Now you notice here in a balanced equation, there's a coefficient of 1 for each of these, so we're going to have 1, 1 here. And since it's asking for liters, we're going to then have to convert to liters. So again, we have 1 mole here. Moles, 1 mole has to go in the numerator to cancel that out. And then we're using our molar volume conversion factor. So we're going to put 22.4 liters of hydrogen in the numerator. Okay, so now we're going to multiply everything in the numerator, divide by what's in the denominator. So we're going to get 50 times 22.4 divided by 65.39. And that gives us 17.1 liters of hydrogen. Okay, so that's an example of a different type of problem where you're just using multiple conversion factors. And again, you just need to be paying attention to your units. Okay, so let's do one more on this, and then we're going to look at your sheet. So this one is talking about butane, about burning it. So this is a combustion reaction. So you're going to have to write out your combustion reaction. So this problem is not giving you the whole reaction. So we're going to write out C4H10 plus oxygen goes to carbon dioxide plus water. We're going to balance it using the Cho method, just like in the last unit. So we put a 4 here, a 5 here, and then we have 8 plus 5 is 13. So that means we need a 6.5, and then we're going to double. Okay, so now our equation's balanced. So now we're going to write down what we're given. So we have 632 decimeters cubed of butane. So 632 decimeters cubed. Now 1 decimeter cubed is equal to 1 liter. So we're going to put this down as 632 liters. And then we're asked for how many molecules of oxygen gas. So we're going to look for molecules. So here we're given liters of our A. Then we're going to get to moles of A. So you always convert to moles first if you're not given moles. Moles of B. Then you have to do mole ratio. And then we're given we're trying to find molecules of B. So remember, going from liters to moles, we're dividing. Moles to moles, we're using our mole ratio. And then moles to molecules, we're multiplying. So we have 632 liters of C4H10, and that's going to be over 1. So remember, if we're going from liters to molecules, we're going to be using our molar volumes. So we have liters here. Liters has to go in the denominator. We have C4H10, and with molar volume, it's also just 1 mole. We do not use our coefficient for our balanced equation. Molar volume is 22.4. Now we're at moles of C4H10. So our denominator is going to have to be moles C4H10. Our numerator will have to be the moles of O2, because that's what we're looking for. That's our B. The numbers here will be our coefficients from a balanced equation. So that's going to be 13 and then 2. Now we're at moles of O2. So now we're going to be using we're going to be using Avogadro's number. So here we have to have 1 moles of O2 in the denominator to cancel that out. And then 6.02 times 10 to the 23rd. And that's going to be molecules of O2. Okay, so let's put that into our calculator. So we're going to multiply everything in the numerator, divide by what's in the denominator. So we have 632 times 13 times 6.02 times 10 to the 23rd. Divide that by 22.4 times 2. And that will give us, our answer is 1, and this should be 3 sig figs, 1.10 times 10 to 26, and this will be molecules of O2. So this is the process that you have to do with multi-step conversions. Either use your island or use your units to set up the problem. Make sure things are canceling out, and then solve. So good luck. And actually next I'm going to pull up your worksheet for homework just to show you how you should go about it. Okay, so on the sheet, the way I want you to work this is you're going to notice that there's actually multiple problems in each problem. What I want you to do is try to do some of the problems that are different from the other sheets we've done so far. So if you look at this first one, it has a grams to grams for the first part. You've already done a whole sheet of grams to grams, so I would not worry about doing that. So I actually cross that out. And then you notice it says what volume of carbon dioxide is produced at STP. So we're actually going to do the grams to volume because that would be something different from the other sheets you've done. If you look at the next problem, it's asking you for grams to moles. That's something different from the other two sheets, so that would be a good one to do. And then it says it's giving you grams. It's asking you to find molecules, so that's another good one to do. So let's see this one here. But then if you look at the last part, it's another grams to grams. You've already done a whole sheet on that, so I would actually cross that out. So when you're going through these, just try to focus on ones that are different. If you see something that's just a moles to moles or grams to grams, don't worry about doing that. I want you to try at least one of the different types of problems, like one of each of the different types of problems. If you need additional practice, then you may do so. But you notice here now we have a grams to moles, we have a grams to molecules. Up here we have a grams to liters. And then if you look down at this one, we have another grams to liters. So here, this one is just like what we did in one of the previous problems. So you don't have to do anything with number 3 unless you want some more practice. If you look at this one, this is a grams to moles. We've already done a grams to moles. So again, that you should only do that if you need additional practice. Here, so when you're going through these, just look for ones that are different. Like I said, you only have to do one of each types that are different from your other two sheets unless you want additional practice. So the whole goal that I have for you with this sheet is just to get very comfortable being able to convert from whatever I'm giving you to whatever you're being asked to find. So good luck on this.